Let's see if we can name this guy right here. So in all of these problems, I guess you can call them, we look for the longest chain or the longest ring. And this one's pretty obvious here. The ring in the middle is clearly the longest, I guess you could call it carbon structure here. And it has 1, 2, 3, 4, 5, 6, 7, 8 carbons. So let me highlight that. It is 8 carbons. So we will be using the prefix oct, and it is in a cycle, so it'll be cyclooct, and there are no, it's all single bonds, so it's cyclooctane. So this right here tells us that our core is cyclooctane. And now let's look at the different subgroups or the different branches off of the main ring. So over here we have a 1, 2, 3, 4 carbon group. It is in a cycle, or it's in a ring. So this is cyclo. This is cyclo. 4 carbons are bute. Cyclobutyl. Ill because it's a subgroup, or it's off of the main chain or the main ring. So that is our cyclobutyl right there. We also have another cyclobutyl right here. 4 carbons in a ring. So that's another cyclobutyl. Cyclobutyl. Up here, we have 3 carbons in a cycle. The prefix for 3 carbons is prop. So this is cyclopropyl. 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 And then down here, let's start with the common names because those tend to be a little bit easier. We have 1, 2, 3, 4 carbons, and actually we have it there and there. 1, 2, 3, 4. These are the same groups. So we're going to be dealing with bute if we do common names. And you see it has this Y shape. We're kind of connected to the base of the Y in either case. So we are dealing with isobutyl. 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 The Y shape tells us that we're dealing with isobutyl. That's both of these right there. Now, we have to figure out how we're going to number, where we're going to number ourselves on this ring. And to do that, we look for the group that is first alphabetically. And this is a little bit of a confusing point sometimes. If this was a tert butyl or a sec butyl, we would consider the B. But when it's isobutyl, it's all considered one word, so we'll consider the I. So we need to compare. We need to compare the I to the C to the C to the C. So the C's definitely went on the I. And then if we look at all of these cyclos, cyclobutyl definitely takes precedence over cyclopropyl. It comes first alphabetically. So let's make our starting point this cyclobutyl, although you could have made it that cyclobutyl as well. So we'll make it that our starting point. And we're going to go in a clockwise direction so that we could get to this one first, so that the next group is only going to be at 2. Otherwise, the next group would have been at 3. So 1, 2, 3, 4, 5, 6, 7. So this is a 1 cyclobutyl. This is a 6 cyclobutyl. This is a 7 cyclopropyl. This is a 2 isobutyl. So this is a 2 isobutyl, and this is a 4 isobutyl. So we want to write them all in alphabetical order. The cyclobutyls win. So we have a cyclobutyl at 1. So we have, let me write it up here. We have a 1 cyclobutyl. We also have a 6 cyclobutyl. We have 2 of them, so it is dicyclobutyl. Dicyclo, let me capitalize since that's where we're starting. Dicyclobutyl. And then, so we got those 2 guys out of the way. And then alphabetically, cyclopropyl is next. So then we have a 7 cyclopropyl. Let me do that in that orange color of the cyclopropyl. Cyclopropyl. 7 cyclopropyl. Got that guy out of the way. And then at 2 and 4, we have an isobutyl. So then we have a 2, comma 4. And we have 2 of them. So it is diisobutyl. 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 And then finally, cyclooctane. So we got these, the 2 and the 4 diisobutyls out of the way. And then we have our cyclooctane. So I'll just write the cyclooctane. 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 And we're done. This was the common naming. Now, if we want to do systematic naming, we would have to use something else other than the isobutyl. And to do that, let me do that over here. What you do is you use your connection point as 1, and you just branch. Let me do this in a color I haven't used for green. So let's make that our core chain. So that is 1, 2, 3 carbons. So it's propyl, propyl. And then on the second carbon, on the number 2 carbon that we are attached to, on the number 2 carbon, you have a methyl group. So this is 1-methyl propyl. That's what each of these. That's a 1-methyl propyl, and then that is a 1-methyl propyl. Another way to think about it, an isobutyl is the same thing as a 1-methyl propyl. Right? This is the propyl part, and then this right here. Let me do that color. That right there is the methyl part. Oh, sorry. This isn't a 1-methyl propyl. Let me be very careful with my numbering. This is the 1 carbon, 2 carbon, 3 carbon. The methyl comes off of the second carbon. So this is a 2-methyl propyl. 1, 2, 3. Methyl comes off of the second carbon. This is a 2-methyl propyl group. And now when we look at it alphabetically, methyl propyl still comes after cyclobutyl. So it definitely won't change the numbering of things. And so it'd still be last. It also comes after cyclopropyl. So if we were to do the systematic naming, it would be 1,6 dicyclo. There's something very strangely fun about this. Dicyclobutyl. And then you have your cyclopropyl. 7-cyclopropyl. 7, it's like a secret code. And then you have your, now this is interesting, you have 2 of these guys, right? Now you don't say di when you have this kind of more complex naming or the systematic naming. Instead you use the word bis. So we have bis, so let me write it. So at the points, we're at 2 and 4, 2, comma 4, bis, this thing. I can just bis 2-methyl, 2-methyl propyl, 2-methyl propyl. So this part right here is the exact part as that part right there. This is the common name. This is the systematic naming. And then we have our cyclooctane. Cyclooctane. And we're done.